Hey there, and welcome to this exclusive note. I'm going to be your mentor today for this masterclass on the massive, hidden infrastructure that literally powers our entire global digital economy. Whether you're just sending a quick WhatsApp message, running a massive global e-commerce brand, or deploying scalable AI systems for a hot new startup, there's this invisible engine running constantly beneath it all. And look, understanding it, that is your absolute key to thriving in the modern tech landscape. So let's get right into it.
Here's a quick look at the syllabus for today's note. We'll be covering 1. The digital economy backbone. 2. How data travels the web. 3. Public, private, and net. 4. The IPv6 digital future. 5. Real-world outages. And finally, 6. Build, grow, and monetize. We've got a ton of high-value, totally practical knowledge to unpack today, so let's jump straight into the first module.
All right, Section 1, the digital economy backbone.
Think about this for a second. Every single second of every single day, billions of data packets, and by extension, literally billions of dollars, flow completely seamlessly across the web. And it all relies entirely on one invisible rulebook. This massive figure right here kind of illustrates the sheer scale we're talking about, 4.3 billion. That's the rough number of unique device addresses that were available in the original internet standard. It sounds enormous, right? But honestly, due to the absolute explosion of modern technology, smartphones, laptops, cloud computing, IoT devices, the whole shebang, that limit is now effectively exhausted.
Which leads us to a really pivotal question. What exactly is this foundational system that keeps everything connected? What's the hidden framework that keeps e-commerce, cloud architecture, and global AI networks from just completely collapsing in on themselves? Okay, let's dive into this. The answer is the Internet Protocol, or IP. IP is absolutely the core communication rule of the Internet. It defines exactly how data is identified, addressed, and routed globally. Think of it as the ultimate set of laws for digital communication. Without IP, there'd be no standard method for devices to locate each other or exchange data efficiently. The digital world as we know it would quite literally just stop functioning.
Moving right along to Section 2, how data travels the web.
Okay, let's move past the textbook definition here and look at the actual mechanics. How does this hidden infrastructure actually move your information seamlessly from point A to point B? The absolutely crucial point is understanding the journey of this data. Honestly, it's a lot like a highly efficient global postal system. First, the data you're sending is divided into chunks. Actually, scratch that. The technical term is packets. They're divided into small, manageable packets. Second, each packet gets addressing information attached to it, specifically the source and destination IP addresses. Third, these packets are routed across interconnected networks, which we call autonomous systems, sometimes taking entirely different paths just to optimize speed. And finally, step 4, they are perfectly reassembled at their destination.
Now, you and I both know we aren't typing out long, complex strings of numbers every time we want to visit our favorite websites. No way. That's because of DNS, the domain name system. DNS essentially acts as the phone book of the internet. It translates those human-friendly domain names into machine-readable IP addresses. The IP address is the actual destination on the network, but DNS, that's how we find it effortlessly without having to memorize a bunch of digits.
Next up, Section 3, public, private, and NAT.
Let's look at the architectural blueprint phase of this note and really understand how we separate secure internal networks from the totally chaotic, public-facing internet. Now, what's really interesting about this slide is this crucial split. In your private zone, your local devices, your computer, your phone, your smart TV, they're automatically assigned private internal IPs, like 192.168.1.1. They use those to talk to each other securely, but when they need to reach out to the broader internet, they don't show those private numbers to the world. Instead, they project a single public IP that's assigned by your internet service provider.
So how exactly do they switch between these two completely different worlds? Well, through NAT, or Network Address Translation. NAT acts as a crucial translator, almost like a security guard, that bridges your private network to the public internet. When your computer asks for data, the NAT on your router swaps your private source IP for the public IP right on the fly. When the data returns, NAT remembers who originally asked for it and translates it back. It saves IP addresses and keeps your internal devices completely hidden from the outside. Pretty brilliant, right?
All right, Section 4, the IPv6 digital future.
You know that 4.3 billion limit we talked about earlier? Well, because of that, the internet faced a massive scalability crisis. So we really need to look at the advanced technology that's actively future-proofing our networks right now. On one side, we have IPv4, the older standard. It uses a 32-bit format, capping out at about 4.3 billion addresses,
And again, because of the absolute explosion of global tech, it's nearly exhausted. On the other side is our solution, IPv6. It operates on a vastly larger 128-bit hexadecimal format. This provides a practically limitless address space. We're talking theoretically unlimited numbers, making it the ultimate enabler for the massive expansion of smart tools, automation, and global AI infrastructure.
Which brings us to Section 5, Real-World Network Outages.
So what actually happens when these critical routing rules are broken, misconfigured, or just straight up manipulated? The consequences can be absolutely catastrophic. Take this fascinating real-world scenario that really highlights why mastery of these systems is so critical. A Pakistani ISP was attempting to block YouTube, but just within its own country, by announcing a specific route to the video service. However, due to a single routing misconfiguration, they accidentally leaked this announcement to the wider internet. And the result? They caused a massive global outage, rendering YouTube totally inaccessible around the entire world for over an hour. It just goes to show you how fragile and reliant the internet really is on precise, accurate IP routing.
Finally, Section 6, Build, Grow, and Monetize.
Okay, let's pivot to the really actionable stuff here. How does understanding these invisible IP mechanics actually translate into high-income skills and real-world business opportunities for you? Well, understanding IP isn't just dry network theory. It is highly monetizable practical knowledge. Just look at these opportunities. If you understand how IP addresses and subnets work, you can architect scalable cloud infrastructure for startups. You can provide high-ticket, real-world troubleshooting when a company's revenue-generating website suddenly goes offline. You can master securing enterprise networks using VPNs and access control lists. If you're building a SaaS business or setting up digital automation, knowing how data actually moves under the hood is exactly what makes you future-ready.
So let's summarize the absolute core takeaway of this note. Without IP, the internet would not exist and the digital world stops functioning. Everything we rely on today, streaming media, cloud computing, social networks, and enterprise data centers, it all stands firmly on the shoulders of the Internet Protocol. It's an absolute necessity for modern society and digital wealth creation.
So, I'm going to leave you with this one thought. Now that you understand the hidden rules of the road, how data is packetized, routed, translated, and scaled for the future, you possess a truly vital piece of industry-grade knowledge. The tools are right in front of you. So what are you going to build next? The digital economy is waiting for you to take action. Thanks so much for joining me for this note, and keep building.